welcome back to Robin's Racing. We're going to make another short video, and you guys, I want to talk a little bit about the relationship between your battery, your ESC, and your motor. Some of the things that people wonder is they look at amperage, right? So amperage and voltage of your motor, your ESC, and your battery, and how to determine what you need. So a couple of things to keep in mind here. The voltage is constant from your battery. It's always going to be whatever the voltage is of the battery. The battery's going to send this all the way to your motor, no matter what it is. So if your voltage is too high, you're going to burn stuff up, right? So voltage is constant. It never changes. On the other hand, your amperage is determined by your motor. Your motor, however much force it's under, determines how much amperage that it needs, right? So what we've got here, we've got a 2-cell LiPo battery. The first thing I want to show you is how do you determine the amperage that this battery can produce, right? The way you determine that, 5,000 milliamps, 30C, right? This information comes off the battery. So a simple mathematical calculation, right here, you take 5,000, I can't write upside down, times 30, divide that by 1,000, right? 5,000 milliamps times 30C, divide that by 1,000, this battery can produce 150 amps. So this battery, 2-cell battery, 35,000 milliamp 30C 2-cell battery can produce 150 amps. Very simple calculation to do. So if that's 150 amps, your ESCs, typically the manufacturer will tell you what they are. For example, BLX ESC right here is 100 amp ESC. So typically your ESCs will tell you what kind of voltage or amperage that they can handle. That is your max amp that they can handle, right? So your motor, or sorry, your battery, you can figure it out. Your ESC, they're going to tell you what it is. Your motor, which is what determines how much amperage you need, they don't tell you what your amp requirement is. The reason for that is because under no load, a motor draws a very low amperage. But under load, or in other words, when it's in your car, depending on the surface that you're driving on, that all determines how much amperage you need, right? So what I'm gonna do is I'm gonna give you a quick little example here with this motor analyzer of effectively the information you can get and how you can kind of get an idea of your amperage. Okay, so the first thing we've got a 3500 Valenian Traxxas motor here. I need to set my poles. This is a 4-pole motor. Now, what I'm looking for here, I'm going to go ahead and run this under no load at all. Okay? So under no load, notice I got about 7.8 volts. That's what my battery's putting out right now. It's not fully charged. Let that go ahead and wind all the way up. We're good. Okay, so in this case, 3.6 amps is all that it drew under no load at 3,580 kV. So this is a 3,500 kV motor. We're pretty close to what we want there. My RPMs was 2,793. Just to show you guys a quick little piece of math on that. So the RPMs, a good way to figure out your RPMs for your motor. We know this is a 3,500 kV. If we look back over here at the screen, my battery was at 7.8. We're gonna say that was 8 volts, right? So let's say 8 volts, right? So some simple math to figure out, the formula for RPMs is going to be RPM. Your RPMs are going to equal your kV times your voltage, right? So 3,500 times 8, right? That's going to give you your RPMs. In this case, it's about 28,000. If you notice, we were at 27,930. So really, we're almost spot on. 3,500 times 8 is about 28,000. That's what our RPM should be. So the spectrum analyzer, the motor analyzer here shows us that this motor's putting out about what it should be putting out at that voltage. Now the question at hand though is amperage once again. So if we want to figure out the amp draw of a motor, again, like I said, it's all based on load. To give you an example of that, I'm going to use this rubber band to put a load on this motor. If you notice, under no load, we had 3.6 amps. So what I'm going to do is I'm going to run this test one more time with a little bit of a load on this motor. Not much. Oh, I cut my rubber band. Notice the harder I pull, the higher that amperage goes up. We got up to about 5 amps on that one. So again, that right there shows you that a motor under load induces your amperage, right? So there is no actual calculation on what the amperage of your motor is. It's all based on the way you run your car. Drag racing or off-road racing, really any kind of racing or any kind of heavy cars are going to have a higher amp draw, things of that nature. So once again, what we talked about earlier with this sheet, so we can determine our amperage of our battery. Our ESC is going to give us the amperage of that. The motor isn't going to give us our amperage, but we can figure out other things such as our RPMs. You can reverse this formula. For example, if you did RPMs divided by voltage, you could get the kV, so forth and so on. kV is typically given to you though. So good thing to know there is that times the voltage can tell you your RPMs. So the higher the kV, the higher the voltage, it's going to give you a higher RPM, right? The lower the kV or the lower the voltage, the lower the RPM. Once again, RPMs, think about it like higher KVs is usually going to be high speed cars, lower KVs are going to be higher torque cars, right? So a lot of your 10th scale on-road cars or drag racing cars, they might be running a 6400 kV motor, whereas your smaller scales, your 8 scale buggies might be running an 1800 kV motor. So that's the relationship between KV. The relationship to KV is literally RPM, right? Higher KV is higher RPM, lower KV is lower RPM. So that's how that works. So basically, again, when you're trying to decide what combination you want to run in your car, the thing you need to understand is what are you doing with your car? So if you're running some examples here, if you're running a 8 scale buggy, for example, typically you're going to want to run probably like a 1800 kV motor with something in the neighborhood of like 150 kV ESC, and then you need a battery that produces 20% more than 150 kV. So a battery that's going to produce somewhere in the neighborhood of say 200 amps, which would be like say a 5050C, which is a very common battery, produces 250 amps. That would be a very safe battery to run with an 1800 kV motor and 150 amp ESC. Short course trucks, maybe you're going to run 130 amp ESC. So you need a battery that's going to produce 20% more than that, so maybe 150 amps. So you could get by with like, a 5030C battery. If you're running like an X-Max or something of that nature, you might want a battery that's like a 100C battery that'll produce 500 amps at a 5000 milliamp 100C battery, right? Because of amp draw. Amperage is really important because if you don't have enough amperage, you're going to get cogging. If you get cogging, that's when your car, when you first hit the gas really hard, it'll kind of dud and then it'll go. Very common in drag racing is because there's not enough amperage. So your batteries can produce the amperage. Your ESC has to have enough amperage to handle that. And then your motor is what requests your amperage. And vice versa, your voltage comes directly from your battery through your ESC to your motor. That's constant. So basically what you need to do is you want to, when you're choosing a motor and ESC combination for your car, is a little simple math to figure out, first off, what do you want, right? So what kV do you need? That's going to determine the motor that you want, the size of the motor. Your ESC just simply needs to be an amperage that's high enough to accommodate what you're trying to do. And finally, your battery, you can do a simple math, which is your milliamps times your C rating to determine the amperage of the battery. The battery always needs to be about 20% more than what your ESC is rated for. An analogy that I give with this, with your battery and ESC, is fire hose, garden hose, fire hose. So if your battery's producing 150 amps and your ESC can only handle 100 amps and your motor wants 150 amps, what happens is your ESC is your garden hose. And when you have something in a situation like that, usually your ESC is going to fail because the amperage going through the ESC, it can't handle the ESC. The cat packs inside the ESC are going to give out and your ESC is going to fail. So I hope this video has kind of clarified things for people as far as trying to help you determine anyways, what motor, ESC, and battery that you need for whatever you happen to be building. Thanks.